Okay, this is the second video on parametric equations and eliminating parameters and applications and things like that. So we're going to start right where we finished last time. Here we have parametric equations. X equals 4 cosine theta, y equals negative 4 sine theta. Keep in mind in this case, our parameter is not t, it's actually theta, but all the same rules apply. So let's see, I want to graph it. So I start by picking values of theta as opposed to t. We'll just start with 0. And then because these are trigonometric things, we'll go with maybe pi over 2, pi, 3 pi over 2, and 2 pi. And see what we get. If I plug in 0, x equals 4 cosine 0, so that cosine 0 is 1, so that's 4. Sine 0 is 0, so that's 0. At pi over 2, cosine of pi over 2 is 0, so that's 0. Sine of pi over 2 is 1, so that's negative 4. At pi, cosine of pi is negative 1, so that's negative 4. Sine of pi is 0, so that's 0 again. 3 pi over 2, cosine of 3 pi over 2 is 0, so that's 0. Sine of 3 pi over 2 is negative 1, that's negative 1 times negative 4, which is positive 4. And then at 2 pi, cosine of 2 pi is 1, so that's 4. Sine of 2 pi is 0, so that's 0. And that's actually right back where we started, which we would expect. Now graph it. This should not be too hard. Let's see, we get the point 4, 0, so we'll say that's right here. Then we get the point 0, negative 4, which is down here. Then we get the point negative 4, 0, which is over here. Then 0, 4 up here. Then 4, 0 over here. And I graph it. And it's clearly, I missed that point, but it's clearly the equation of a circle with a radius of 4. One thing to keep in mind though, and we mentioned this last time, these parametric equations have an orientation. So we have to make sure we put the orientation on the circle. And in this case, at 0, I'm at the point 4, 0. At pi over 2, I'm at 0, negative 4, which means I'm actually going this way, clockwise around the circle. And as time keeps going, I just get a circle that repeats itself over and over and over and over again. And it just spins around that. If I restricted myself to thetas from, say, 0 to 2 pi, then I would just get one spin around the circle. But now, well, if that's the equation of a circle centered at the origin, because it is, and the radius is 4, then we know the equation in rectangular coordinates should be x squared plus y squared equals r squared, which is 16. And now the question is, how would I do that? If these are my parametric equations, how would I eliminate the parameter to make this look like this? Last time we isolated a variable, the t, the parameter, and then substituted that into the other parametric equation to eliminate the t. Here, I don't really want to isolate the theta. I'd have to take a cosine inverse and do all of that. And that's really messy. So there's actually another algebraic trick you can do. I'm going to square the top equation. Square the left and square the right. And I get x squared equals 16 cosine squared theta. Make sure to square both things. I'll square the bottom equation, and I get y squared equals negative 4 squared, which is 16, sine squared theta. Now, I'm going to combine those two equations. And by combine, I mean I'm literally going to add them together. On the top, well, on the left, I get x squared plus y squared. On the right, I get 16 cosine squared theta plus 16 sine squared theta. On the left, I'm just going to leave it alone. On the right, I'm going to factor a 16 out, and I'm left with cosine squared theta plus sine squared theta. But we know from our Pythagorean identity, cosine squared plus sine squared is 1, so this just becomes x squared plus y squared equals 16. The equation of a circle centered at the origin of radius 4. Exactly what I wanted. And the point is, there are actually several different ways to eliminate parameters. You can do substitution like we did before. You can do this trick here where you square both sides. There's lots of ways to do it. And you're just going to get to mess around with it for homework to see if you can kind of work through all the algebra. Give me 1 second, so I think a student might have just shown up. Nope, not my student. Okay, good. So now, we're going to look at an application. That old throwing the football thing that we were mentioning in the last video. And you will need your calculators for these, so I'll get mine. Okay, so say we have this. I have a problem listed here. Suppose I throw a football with an initial velocity of, I don't know, we'll say 50 feet per second. At an angle of 40 degrees to the horizontal. That should work. Find parametric equations that can actually model that situation right there. In order to do this, your book lists 2 different types of parametric equations for motion. One of them is called uniform motion and the other one is projectile motion. We're going to focus on projectile motion, and these are in your book so you don't have to memorize them. And the equations are x equals v sub 0 cosine theta plus x sub 0 and y equals negative 1/2 gt squared plus v sub 0 sine theta plus y sub 0. Okay, so let's see. Those are my standard equations. They should look similar to the regular projectile motion equation that you're used to, this one in particular. Now we just need to kind of figure all that out and where everything goes. The theta right here equals your angle to the horizontal. V sub 0 is your initial velocity. Oh, I had that right here. X sub 0 is your initial distance horizontally. Y sub 0 is your initial height. G is the acceleration due to gravity. Your acceleration due to gravity, we mentioned last time, there's actually 2 ways you can do it. G can either be 32 feet per second squared, or it can be 9.8 meters per second squared. That's dictated by the problem. Since my velocity is in feet per second, we're going to use this right here. But in order to do it, I actually need an x sub 0 and a y sub 0. So I'm going to kind of, well, create a picture, draw a graph. And I'm going to set it up so that when I draw my graph, I'm standing right here when I throw the ball. That's my really bad picture of me standing there. So I'm right on the axis. When I throw the ball, I throw it with an angle from the horizontal of 40 degrees. So that's 40 degrees right there. My initial x value, x sub 0, well that's 0 because I'm right on the axis. My initial y value, well that's the height I throw it at. And to keep things even, we'll just say it's 6 feet. So now I have a y sub 0, an x sub 0, I have my theta, I have my initial velocity. So I should be able to set up these equations. X is equal to 50 cosine 40 degrees plus 0, so we can just leave that off. Y equals, oh, I'm sorry, I left off the t. Yes, I did. there should be a t right here. I need my variable, my parameter. Y is equal to negative 1/2 32, which is just negative 16 t squared plus 50 sine of 40 degrees plus y sub 0, which we said was 6. And again, I left off my t. My t's look like pluses, so I sometimes forget them. There's a t right there too, my linear factor. Now I have some parametric equations. Now I can actually solve the problem. So let's see, if I'm throwing a football, well, I guess I would want to know how long it's in the air. If I'm going to launch it this way, and I want it to go out to a receiver, I want to know how long it's in the air until it hits the ground. Well, let's see, what could I do with these equations? Well, when it hits the ground, the y value has to be 0. So, set the y value equal to 0 and then solve for time. That'll tell me when it's on the ground. So I get 0 equals negative 16t squared plus 50 sine 40 degrees t plus 6. And now just solve that out. This is not going to work nicely, so we're going to have to throw it into our calculator. I'm going to move everything around. So we'll get 16t squared minus 50 sine 40 degrees t minus 6. Throw it into your calculator and get the solution, and we'll get, let's see, negative 50 sine 40 plus or minus the square root of that squared, I'm going to run out of room, of negative 50 sine 40 squared minus 4 times 16 times negative 6. All over 2 times a, which is 16. I would suggest you pause the video right now and actually do all of that math out. This video is going to be a little bit long now, so we're going to stop here. You guys can do the math out, and I'm going to make one more video solving a few more questions and information we can get out of this.